Polar and rectangular representation of a sine wave. A sine wave is normally represented through a simple formula. Vt equals d plus a sine 2 pi ft plus theta. In this equation, d is the DC offset, a the amplitude, f the frequency, t the time variable. When given a value, this gives an instantaneous voltage at that time, and theta the phase angle. As can be seen, the DC offset just moves the graph up or down depending on the value. Different representations of a sine wave. As it is impossible to add, subtract, multiply and divide sine waves in the form Vt equals d plus a sine 2 pi ft plus theta, it is necessary to convert it into other forms. This is why polar and rectangular representation of sine waves are necessary. It is possible to add and subtract waves when they are in rectangular form and multiply and divide waves when in polar or phasor form. The polar representation of a sine wave is in the form r theta, where r is the radius or amplitude of the sine wave function, and theta is the angle that r makes with the x-axis from 0 to 360 degrees, or 2 pi, which is also the phase angle in the original representation of a sine wave, as can be seen from the diagram below. The rectangular representation of a sine wave takes the form Vt equals it plus qt, or v equals x plus yj, where it or x is the real part and qt or y is the imaginary part, as can be seen from the diagrams. To go from polar to rectangular or rectangular to polar, there are very simple equations to help us go between the two representations. To go from polar to rectangular, we use the equations x equals r cos theta and y equals r sin theta. To go from rectangular to polar, we use the equations r equals square root x squared plus y squared, and theta equals arctan y divided by x. Significance of these results to electrical engineering. Due to these new representations of a sine wave, it is now possible to apply common laws found in DC circuits to AC circuits, such as Ohm's law, KCL, KVL, and nodal analysis. This is because the original expression for a sine wave did not allow for multiplication and division, or addition and subtraction. Now that we have two new forms to express a sine wave in, it allows us to multiply, divide, add, and subtract values in AC circuits. Expressing sine waves in polar form allows us to multiply and divide values, and rectangular form allows us to add and subtract values. Thanks for